I'd like to welcome you guys again to today's lesson, right? So we're gonna look at differentiation rules. Differentiation rules, okay? Differentiation rules. Now, once you master the differentiation rules, then you'll be able to apply them for finding the derivative of any equation you will have there. And this will also assist you in functions. Particularly myself, I like what they call the Newton's method. You can search it up when you have time. The Newton's method. This is a very, very complex while easy method that is applied at varsity level, and you will apply it there, and it relies on differentiation rules. Okay, so quite nice one there. But then these rules, guys, there are only 3 rules, so quite simple. The rule just says, but before we even talk about the rules, let's understand, guys. If I have, let's just say I have 2x squared, and let's say I have 2x. Right. I want us to understand something that we call a coefficient. What is a coefficient? 2 here would be a coefficient. It would be a coefficient of x squared. While 2 here would be the coefficient of x. Let's have some more. Let's say we have 4x cubed. There, what will we have? 4 is going to be the coefficient of what? The coefficient of x cubed. In simple words, a coefficient is going to be a number attached to a letter. You hear me? A coefficient is a number that is attached to a letter. Now that letter can have any exponent. As long as the number is attached to a letter, we call it a coefficient. And a coefficient is usually written first before the letter. But you must know that in between that number and the letter, it's a multiplication sign. Because when you have 2x squared, it's actually 2 multiplied by x squared. So in the middle, you'll always have multiply. If you have 2x, this comes from 2 multiplied by x gives you what? 2x. And then 4 multiplied by x cubed gives you what? 4x cubed. So that's what we must know, that between a coefficient and a letter, it will always be the multiplication sign. Good. Now, what if I had negative 3y squared? What do you think will be the coefficient there? Can you write it in the comments there? So that's very correct, okay? So negative 3, we would say there, negative 3 is the coefficient. It is the coefficient of y squared. So negative 3 is the coefficient of y squared. Good. Now we understand what is a coefficient, isn't it? By now, at this stage, I also know that you understand what is an exponent. That one, I would like to trust you guys that you do know what is an exponent. Good. Now, the 3 rules, right? The first rule, or rather, for all the rules, for all the rules, 3 rules, all the 3 rules, we are just simply saying multiply. The steps are to multiply. Multiply the coefficient. Multiply the coefficient by the exponent. That is the first step of the rule. You multiply the coefficient by the exponent. And then after that, subtract 1 from the exponent. And then simplify if possible. Simplify to leave the answer with a positive exponent. Simplify the answer to leave it with a positive, right? Let's write it with a positive exponent. Perfect. That is the rules, guys. That is it. If you can just do that, you'll be able to apply them efficiently. So let's have example number 1. Example number 1. Now, the question is just going to say differentiate. And right now, we are only going to work with x. Right. So, the first one, let's just say we had 5x cubed. And then the second one, let's just say we had minus 2x squared. And then let's say the third one, for the third one, let's say we have 4x to the power of negative 6. Right. Let's say we needed to differentiate there. Okay. Now, when you have to differentiate, the thing is that we have 3 notations that we use. Okay. When you have to differentiate this, there are 3 notations that we use. Okay. So we are gonna be working with things such as f prime of x, g prime of x, k prime of x, etc. Okay, then we're going to be working with things such as dy over dx, dz over dk, right? And then dx over dy, etc. Okay, then the other notation would be dx, right? Okay, we can just say dx, and then we also have dy, and then we have dz, right? And then it will just depend. But then you know what? We're gonna start with a simple notation. We're gonna start with these ones here. Okay, this one here is called the Leibniz's notation. We also have the Newton's method, which is you use y and then you put a dot, and then you can also be using y and 2 dots there. This is the Newton's method and stuff. Okay, then if there are more, you'd be putting things like this, but this is like in varsity if you're going to be doing physics at varsity level. Okay, but then now, for us to make things easy for us, we are going to be working with the first one for now. So that means I must change these problems. Okay, so let me just change them real quick. They will be the same problems, but I'm going to rephrase the question. So let's say the question says find f prime of x, which means find the first derivative. If what? Number 1, if f of x is equal to 2x, we had 5. Let's put it as 5x cubed. And then number 2, if f of x is what? Negative 2x squared, right? If f of x is negative 2x squared, and then let's say that number 3, f of x is 4x to the power negative 6 is 4x to the power negative 6. Now, how do we answer the questions there? Now, for the first one, we're going to write solutions this side, right? For number 1, since f of x is equal to 5x cubed, do you remember what the rule says? The rule says that you must first multiply the coefficient by the exponent. That is the first thing. So which one is my coefficient here? My coefficient is 5, isn't it? 5 is the coefficient of x cubed. Now, I have to multiply the coefficient with the exponent. That is the first thing I must do. So if I do that, right, that means I'll be finding the derivative now. Stuff. Right, so to find the derivative there, right, to find f prime of x, would say 5 times 3, okay? Because we're multiplying the coefficients. So 5 multiplied by 3 is what? Is 15. Perfect. And then now that I've multiplied the coefficients, I should write the letter x. But here now, here I must follow the rule. The rule says subtract 1 from the exponent, from the original exponent. Remember the exponent is 3. I must say 3 minus 1. Now 3 minus 1 gives me 2. And then I'm done. I found the derivative. Right. Quite easy, ne? Let's go to number 2. For f of x, we have minus 2x squared. The rule says, first of all, multiply the what? The coefficient with the exponent. So I'm going to say, to find my derivative, I'm going to say the coefficient, which is negative 2, and multiplied by 2, I will get negative 4. And then I subtract 1 from the exponent. What is 2 minus 1? 2 minus 1 is just 1. So there's no need of writing it because we have mathematical eyes of seeing the 1 there. Perfect. Number 3. F of x is equal to 4x to the power negative 6. Now it says we must find the derivative, isn't it? So to find the derivative, you are simply going to start by multiplying the coefficient with the exponent. 4 times negative 6. That should give you negative 24. Then you write the letter and then you subtract 1 from the exponent. So we're going to say here minus 6 minus 1. Okay? So the answer there would be what? Would be minus 7. Then this would be your derivative. Right. Quite nice and easy. Quite nice. Hope you got it, guys. Remember, the rule just says multiply the exponent with the coefficient. Then you subtract 1 from the exponent. Now, let's go to the next ones. Find k prime of x if, number 1, k of x is equal to 3x to the power minus 3. Okay? Number 2, k of x is equal to 2x to the power 6 minus x to the power 5. Make it quite interesting. Number 3, k of x is equal to 5x cubed minus x cubed. Right. Those are what we have there. Now these ones, they look kind of scary, but no, it's the same thing that we're gonna do. So let's have our solutions this side, okay? Now for number 1, we are going to say we apply the rule. Since k of x is equal to 3x to the power minus 3, when I'm applying the rules, please listen to this. I want you to listen to the English here. When I'm applying the rules, I immediately write k prime of x when I'm applying the rules because I'm finding the derivative. Please, that statement, let it always stick with you, that when I'm applying the rules, I must write k prime of x because I'm finding the derivative. So applying the rules is the same as saying you are finding the derivative. So how do we find the derivative, or how do we apply the rules? We simply say the coefficient is 3. We multiply that coefficient by the exponent. So you say 3 multiplied by negative 3. You put that in your calculator if you can do it by head. 3 multiplied by negative 3. It will be negative what? Negative 9. Then you write the letter, and then after writing the letter, you go to the exponent. You say that exponent minus 1, meaning you're going to say minus 3 minus 1. Okay? You're going to say minus 3 minus 1. Then I'm simplifying the derivative here. My derivative will be minus 9 to the power of minus 4. Where did I get minus 4? I got it by subtracting 1 from the exponent. Minus 3 minus 1 is minus 4. Where did I get the negative 9? Remember, I said the coefficient multiplied by the exponent. Good. Got it? Hope you got it. Number 2. Now for number 2, right, what you must realize is that it's 2 terms. So I must write all of them first. 2x to the power 6 minus x to the power 5. Now, I'm still going to apply the rules now. I'm going to apply the rules, so that's why I'm writing k prime of x. And then I'm going to say here, the coefficient is what? The coefficient is 2. What about the exponent? The exponent is 6. I multiply the coefficient and the exponent. 2 multiplied by 6 is 12. Then I write the letter. Then I have to say from the exponent, I subtract 1. I say 6 minus 1. Now 6 minus 1 is simply 5. So I write it there. Then I go to the next one. I'm going to say the coefficient multiplied by the exponent. Here it looks like there's nothing for the coefficient. But actually, we must know that there is a 1 there. You must have what I call mathematical eyes. You must see the 1 there. Okay, so 1 is there. So I have to say minus 1 multiplied by 5. You can put it in your calculator if you can do it by head. Minus 1 times 5 gives you minus 5. Okay, minus 1 times 5 gives you minus 5. And then I go to the exponent, which is 5. I subtract 1. I say 5 minus 1. The answer is what? The answer will be 4. Then I've gotten my answer there. So please remember, the rule is simply saying multiply the coefficient and the exponent, and then after that subtract 1 from the exponent. Number 3. Number 3, I have k of x is equals to 5x cubed and then minus x cubed. Right. Now, to get the answer there, simply we do the similar thing. Okay, you are going to say this coefficient is 5, right? And then the exponent is 3. So you're going to say 5 multiplied by 3. 5, 10, 15. So you get, but do you see what I forgot to write? I forgot to write the stroke there. The stroke should be there because I'm finding the derivative of the function k of x. So 5 times 3, I get 15, and then I see now 3 minus 1, I get it as 2. Okay, then minus 1 times 3, it's minus 3, and then 3 minus 1 is 2. Then I've got the derivative. Okay, so I hope that was clear. Now let's go to more complex problems. Right, find g prime of x if number 1, g of x is equals to the root of x cubed minus x squared. Now this one, guys, is for you. The number 2, g of x is equals to 1 over x to the power of 4 minus x to the power of 7. Right, now this one, guys, is for you because I did the hard ones. Now I want you guys to do these simple ones. Okay, so for you to do these problems here, because they're a bit complex, they're just complex because you need to know some bit of knowledge from grade 11. Now, particularly, there is this law that we learned in grade 11 that is talking about what you call, it's talking about sets, right? So the first one says that if you have the nth root of a to the power m, right? What it says that the nth root of a to the power m, if you have something like this, what you simply do is that you write a and then this exponent, right? This exponent, you write it on top. You divide it by the root. Okay, if the root is a square root, you're gonna divide by 2. If the root is a cube root, you're gonna divide by 3, and then that is the n part there. N is the nth root. Okay, so the thing is that why am I bringing this into the picture, right? It's because that's the situation we have here. We need to make sure that this looks like this first before we can apply the rules, because let's be honest, the rule says you must multiply the coefficient with the exponent, but the question is, where is the coefficient here? You see, you can't see the coefficient, so you must make sure that you simplify it first. So what you're gonna do there, let's write our solutions this side, right? So let's say our solutions would be this side. For the first one, right, since we have g of x is equals to the square root of x to the power 3, right? The square root of x to the power 3 minus x squared. So what is the thing that we must do first? You must first simplify g of x. I'm writing it as g of x because I have not applied the rules yet. I I want to simplify g of x so that I can see the coefficient. Now here I'm gonna turn this and remove the root sign, meaning I'm gonna write it as x to the power of 3 over 2. Where does the 2 come from? The 2 comes from the fact that it's a square root. We don't write the 2, but you must have mathematical eyes of seeing the 2 there. Okay? Then you have minus x squared. Good people, when it's like this now, it's easy to find that, to see that, the coefficient here is 1. That's the coefficient. And the exponent is 3 over 2. Then now you can apply the rules. That's where I'm going to write g prime of x, because now I'm applying the rules. Now the rule is that you multiply the coefficient and the exponent, right? So I'm going to multiply the 1 times the 3 over 2, right? I can even write it here, 1 times the 3 over 2. Okay, if I don't have the answer yet. And then I have to say the exponent minus 1. Remember, I have to say 3 over 2 minus 1. And then here I have minus 1 times 2. That one is easy. I can just write it as minus 2, because minus 1 times 2 is minus 2. Okay, is the coefficient times the exponent. And then from there, I have to say 2 minus 1 is what? Is 1. So then I'm left with simplifying. So what is 1 times 3 over 2? It is 3 over 2, right? What is 3 over 2 minus 1? So that gives me a half, okay? 3 over 2 minus 1 gives me a half, right? And then minus 2x. Very good. Good people, if you leave it here, you are going to get your full marks. Ne? If you leave it here, you are going to get your full marks. But if you want to show them that I know my maths better, I can actually go further and now say, so this is just optional. I'm going to write that this is optional. So you can also then say now, you can actually write this as 3x to the power of a half all over 2 minus the 2x, because this thing is all over 1. So we're just saying the numerator times the numerator, denominator times the denominator. Okay, so I like to, so optionally, right, we can also write this as g prime of x is equals to, you don't have to say this times that, because you are not applying the rule. If you're applying the rules again, that will be the second derivative. So we're already done. So you should write this as, right, but then you can write this with the positive exponent. So meaning you can write this as x to the power 5 and then minus 7x to the power 6. This is what you can also do. But the main important thing, or the most important part, is to know how to apply the rules by changing those funny looking terms. You must change them so that you are able to see your coefficient, and then you should be able to get the answers. Okay, yeah, quite a good run. Let me just go through it again. Remember, for number 1, we had the root of x cubed and minus x squared. The first thing we did here was to remove the root. How do you remove the root? By applying this law of exponents. So we put 3 divided by the 2 there, okay? Then after that, we can now see that our coefficient is 1. So when I'm applying the rules, I write the prime, then I say 1 times 3 over 2 is what? Is 3 over 2. Then I say 3 over 2 minus 1. 3 over 2 minus 1 is a half, okay? Then I have to say here minus 1 times the 2, it's minus 2, and then I get my answer there. So let's proceed. So let's just say now they give us the following. Now, sorry. Let me just fix this for a minute. It's not bad. It's fine. Yeah. So let's just say they give us, right? They say, find the derivative of p of x if, number 1, if our p of x is gonna be equal to the cube root of x to the power 4 minus 2 over x, and then number 2, let's just say we have p of x being equal to let's say the fourth root of y to the power of 6, right? Minus 2 all over, okay, let's just say y cubed plus y divided by 2. Oh, yeah, we made it quite interesting. So try this one, give them a shot, and then we'll look at the solutions. All right, so for these ones here, still gonna be applying the knowledge we just learned, especially from grade 11 there, or 10. Right, so let's have our solutions this side. The first one, you have p of x being equal to 3, and then cube root of x to the power 4 minus 2 over x. Good people, the first thing I want to say is that do not write this. Please don't. Agree, we know that this we must convert it and have the have it in the form whereby you can see the coefficient. That form is ax to the power n, meaning you must always have it in this form whereby you have the coefficient and then the exponent. So for us to turn this into that form, we have to simplify. Now for us to simplify this, we first start by writing p of x is equals to, then you're gonna write x to the power of 4 over 3. Majority of you managed to do that, which is perfect, but don't write p prime here because we're still simplifying. We have not applied the rules. The rules is when you're multiplying this and that. Okay, right here, please also guys, this one you must also simplify it at the same time. I agree, you are just done simplifying this one. This one you must also simplify it. This one, how you're gonna simplify it, that you're gonna write minus 2, then this you're gonna write it on top, right? You're gonna bring it on top, meaning you're gonna write it as x, but make sure that since it had exponent 1, here you're gonna give it minus 1 as the exponent. That is the first thing. Then now that it is in this form whereby we can see the coefficient and the exponent, now we can apply the rules. That's when I write p prime. Okay, so now this times that, 1 times 4 over 3 is 4 over 3, and then I have x. Now what is 4 over 3 minus 1? I believe that should give you 1 over 3 if you go to your calculator there. Perfect. And guys, when you apply the rules here, you must also apply the rules there. Don't say, I will apply the rules here on this one, I'll still be simplifying it. No, when you're applying the rules, you're applying them once at the same time. So minus 2 times minus 1 is gonna be positive 2, and then you say minus 1, you have to subtract 1 from the exponent, you will get minus 2. So guys, that is your answer there. And then let me leave it there. Let me not leave it with a positive exponent, because by the way, you'll get your full marks there. Number 2, we're gonna have it as p of x, and then the fourth root of y to the power 6 minus y to the power 3 plus y all divided by 2. Now for this one, firstly, I'm gonna write it here, right? So there you're gonna want to write it as y to the power of 6 over 4, right? And then here on this part, guys, you're gonna have to split. This denominator is gonna have this, and then this is gonna be having that. So you're gonna have to have minus y cubed all over 2 minus y over 2. Yeah. Why do I have minus and minus? This is because you distribute the minus inside. You multiply the minus by that y cubed, and then you also multiply the minus by that plus. Okay. That's what you must first do there. So this minus that is outside, you must multiply it inside. Then from there, you're gonna write it as what? As 6 over 4. Then you're still gonna simplify. You're gonna write this as minus y cubed, and then the 2 you're gonna take it out on the top so that you have 2 to the power of minus 1. We said between this and that is multiplication, right? and then here you're gonna have minus y, and then that 2 there you're gonna give it minus y. Then from there, guys, you're gonna want to rearrange it so that it looks proper. So you're gonna have 6 over 4, then you're gonna have minus 2 to the power minus 1, and then y cubed, and you're gonna have minus 2 to the power minus 1 times y. Then now you can apply the rules. That's when now I can write that p prime of x will be equal to the 1 times the 6 over 4. It's gonna be 6 over 4, and then I'm gonna have y. Then 6 over 4 minus 1. That is the same as saying it's gonna be 2 over 4, and then minus 2 to the power 1 times 3. You put it in your calculator. You put minus 2 to the power minus 1 times 3 in your calculator. I believe that should give you minus 3 over 2, and then y, and then you say y, 3 minus 1 is 2. Then here you're going to say minus 2 to the power minus 1 times the 1 that is there, the exponent is going to be minus a half, and then you say y to the power of 1 minus 1. I can remember the exponent is 1. You must remove 1, so it's going to be 1 minus 1. Here, sorry, here 3 minus 1 was 2. So p, that is going to be 6 over 4 y to the power of when you simplify 6 over 4, it gives you 3 over 2, and then here you're going to have a half, and then you can have minus 3 over 2 y squared, and then you're going to have minus a half. Now, I'm going to remove this because 1 minus 1, remember, it's y to the power of 0, which is 1. Remember that in grade 10, we said e to the power of 0 is 1. Okay, so that's what we'll have. And that's the answer there. Yeah. No one got it right, but then it's fine, guys. You know, you are learning, and make sure that we are applying the rules properly. So I think here what might have confused you is to split this, right? Knowing how to split that. So especially splitting when there is a minus is tricky. So you have to multiply the negative inside, negative times the y cubed. Say, what if you wrote it together? Like what? So this is the last one I'm gonna have on what you call on that part of having on that part of dealing with p of x, g of x, you know, like those normal notations, right? So let's say you have, so they say find we did k, we did p, we did all of them as h of x. So find h of, so if find h prime if h of x is equal to the square root of x cubed, right? Oh, by the way, I think here I had made a mistake here. I was not supposed to put p of x, okay? So sorry for that. I was not supposed to put p of x. So hoping you would just shout out that to me. I was not supposed to put p of x because the variable we're working with is y. So we're supposed to write p of y, okay? Even here you're supposed to write that. And so this is y there. So p of y equals to that. And p of y equals to that. And then p of y equals to that. Then here is p prime of y because the variable we're working with is y. Okay, so you must be careful. The variable is actually important. And that's what now we are coming to next. I'm gonna make an example. So this is the first example. Let's say they wanted that if you are given this and then they say plus 2, yeah, let's say they say plus 2 only. Right. For this problem, the solution would be that you have to simplify h of x first. So you're going to have h of x is equals to x to the power of 3 over 2 plus a 2. Then now you apply the rules. That's why you write h prime of x. Now you're gonna say the 1 that is here times the 3 over 2, the answer will be 3 over 2. And then you say 3 over 2 minus a 1, it's gonna give us a half. And then you say, now this one doesn't have x, isn't it? So if it doesn't have x, the letter, if the coefficient is not attached to the letter, the answer is just 0, because the derivative of a constant is 0. So the answer is just 0. So you can say plus 0 there. Okay. So your answer would be simply this. So the first thing you want to do there to get the answer is that you're going to say h prime of x would be 2 times the 4 is going to be 8, and then you say cubed, because 4 minus 1 is 3. Then here you're going to say minus 3 times 1 is simply minus 3, and then you're going to have x to the power of 1 minus 1, which is a 0. Yeah, it's essentially that. And then here you're going to have 0 because it's a number. So your answer would simply be h prime of x is equals to 8x cubed minus 3, because this is 1. And then, yeah, you would be done. So I see Mr. Fatai, you said, wow, we got it correct. That's good. Do I have others? Okay, we don't have others. Okay, so that is what we have there. Very good stuff, guys. So you just have to make sure that if it's a constant, it's 0. Right, and then lastly, what if we had h of x to the, is equals to maybe the root of x minus 8y plus 6x. Please try that one. For this one, remember there is a root there, so we need to remove it. When we are removing the root, we are not yet applying the rules, so we must still write h of x, not h prime. So that means this part I must write it as x. The exponent here is 1, so I'm gonna write 1 at the top, then I say divide. This is a square root, it means there is a 2 there, it's a square root, so I have to say over 2. So this becomes x to the power of 1 over 2. Okay, then I have minus 8y, and then I have plus 6x. Then now I can apply the rules. When I'm applying the rules is when I'm saying the 1 that is here times the half, the answer will be half. Then I have to write the x, then I have to say half minus 1. I have to say half minus 1. It will give me what? Minus a half. That's the one I write. Then here, it says h of x. It means the variable, the letter we are respecting is x. Anything that won't be x is regarded as a constant, which means this thing is a constant. It's like any number. So we should say minus 0, okay? We should say minus 0, or we can just say plus 0. Yeah, we can just say plus 0. And then here, 6 times 1 is going to be 6, and then you say 1, the 1 that is there, 1, then minus 1 is 0. Okay, so your answer there would be half this plus 6. So what you must remember is that if I'm saying h of x, it means we are respecting x, the rest of the variables become constants, and you just write 0 for them. Okay, right. Now my last one for you guys for today will be this one. Let's say you have k of x being equal to, or maybe let me use k of y being equal to minus 3y cubed plus 2x squared, and then minus x y cubed. Right, very good one there. Please give it your best. It's a very nice one. And then yeah, so get the derivative. So the first thing we want to do here is that realize that you are working with y as the respected variable. Anything that won't be y, meaning we take it as a constant. So we since already these, I can see the coefficient, the exponent, I can see the coefficient, the exponent, the coefficient, the exponent. So there, I'll be able to just apply the rules. So that's why I'm gonna say the answer there would be k prime of y. Now, I have to say minus 3 times 3, that will give me minus 9, isn't it? And then I say y, then I say 3 minus 1 is what? Is 2. What about here? I don't have to apply the rules on here because everything here is just x and we are respecting y. So all of this is taken as a constant. And since we take it as a constant, we're simply going to say its derivative is 0 because there is no y there. Okay. Now, if I check here now, if I check here, I have x. We don't respect x, but it's attached to the y. So if it's like that, I need you to take this as a number, as if you had something like 2y cubed. So you take it as a number. So you simply apply the rules as normal. The coefficient times the exponent, meaning you're gonna say minus x times 3, the answer will be minus 3x, minus 3x. And then you write the y that we are respecting, then you say 3 minus 1 is what? Is 2. So therefore your final answer will be k prime of y is minus 9y squared minus 3xy squared. Would you look at that? How beautiful is that? So that would be the answer there, guys. Wow. We covered quite a lot. We covered quite a lot. But with the remaining time that we have, we can actually look at more problems. Okay. Let's see. What if we are given? What if you are given f of x, ne? And you have to find the first derivative, which is f prime of x. Let's say you are given this as 2 to the power of x, ne? 2 to the power of x minus the root of y squared, right? And then plus x squared, plus x squared y squared. Wow, what a beautiful one. This is very nice, guys. Okay, so how would we find the derivative there? Work on it, guys, work on it. So how do we do that? Well, I actually realized that I gave you something beyond your level, but I wanted you to see if I wanted to see if you're really gonna see it. Right. So far, guys, remember the rule said if you have, right, the rule says if you have your y as being equal a to the power of n, right, the rule says when you find the derivative, you're going to say this times that, meaning the coefficient times the exponent, which is an, and then you're going to say to the power of n minus 1. Okay, this is just another notation that you are seeing there. Okay, but we'll talk about we'll talk about this. Okay, so now guys, the thing is that you only apply that if x is the base. Okay, if x is the base. But when you check here, 2 is the base and x is the exponent. Now when it's like that, you can't apply that law that says you're gonna say this times the one that is here, because the base is not x, but the base is 2. Okay, so when it's like that, you need to be very careful. So you won't really get something like this, by the way. So this one, I'm just quickly gonna write a beautiful not applicable there, because this one we can't solve it, right? Then the next one here, it's okay, but then now you have y all over, you don't have x. So because you're only dealing with y, the whole thing you would take it as a what? The whole thing you take it as a constant. Okay, and because you take it as a constant, then here we're gonna simply say plus 0. Okay, then what about this part? Now this part was quite interesting because you have x and y, but you have to focus on the variable that you are respecting. We are respecting x, which means this is the x that we are respecting. That means the coefficient must be y squared, meaning this y squared, you're going to take it as a coefficient. even though it's written on the right, but because it's attached to x squared, this is the coefficient. This is the coefficient of what? Of x squared. If you remember, we started with learning about coefficients. Okay, so that means the coefficient, the whole y squared is a coefficient because it's attached to x squared. If I take you to where we started, if I take you to where we started the lesson, when I started the lesson, I started the lesson on coefficients. To say coefficient is a number attached to the letter, right? So it similarly there, right? Similarly there, that y squared there is gonna be, the whole of it is gonna be a coefficient, while the x squared is going to be the letter you are respecting. So remember, we always say the coefficient times the exponent, meaning you're gonna say y squared times the 2. Okay, you multiply the coefficient and the exponent. So there what you're gonna have is plus. So y squared times 2 is going to be 2y squared, and then the x squared, now its exponent, you're going to say minus 1, the answer will be 1. So therefore your answer will be, let's just say 2y squared x, because these ones we don't count them. Then this will be your answer there. Now guys, the other notations that you're going to be having, right, it's like dy over dx, and then you're going to be dealing with dx, and then you're going to have something in there. Okay, so this is called the differential notation. This is called the Leibniz notation. Leibniz notation. Okay, it was developed by Leibniz, and then here it's called the differential notation. Differential notation. So guys, using a different notation, it just means you have to understand the notation, but we're applying the same concepts. Now the thing is, when we're using this one, let's have examples. For example, number 1, let's just say I have my y is equals to 2x cubed minus 4x squared. Now, so what this notation tells you is that at the top there, whatever will be the variable here is the subject of the formula, is the subject of your formula, of your equation. Okay, while this one is the variable we are respecting, is the variable we are respecting. Okay, so everything will be, we respect x. So for example, you see here, since this is y here, I have to write dy to say the derivative of the function that has y as the subject with respect to x, because the letter there that we are respecting is x, right? So they say find dy over dx. So what you simply do, you apply the rules again. 2 times 3 is going to be 6. Then you have x. 3 minus 1 is 2. Negative 4 times 2 is what? Negative 8. Then you have x, because 2 minus 1 is 1. Then you are done. But the most important thing is that you only write dy over dx when you are applying the rules, right? When applying the rules. You only write dy over dx when you're applying the rules. In a similar way, we said you only write f prime of x when you're applying the rules. You also write only dy over dx when you're applying the rules. You can even check the problems we did before. We can do them using that notation. For example, this problem here, we can write it as y is equals to 2x to the power 4 minus 3x plus 8. And then I can find the dy over dx by simply saying 2 times 4 is what? Is 8, and then x, 4 minus 1 is 3. 3 times 1 is going to be negative 3, and then 1 minus 1 is going to be 0. Then a constant is simply 0. So my answer, my dy over dx would be equal to 8x cubed minus 3. Okay. So any problem, all those problems we did, so dy over dx just works in a similar way as f prime of x or k prime of x. Let's have number 2. Let's just say we have a number 2. Y is equals to the root of x cubed, right? Minus 8x squared. So when you find dy over dx, you can't find dy over dx yet before you simplify. So when you are simplifying, don't write dy over dx, simply write y. So you're gonna have y, and then you write x to the power of 3 over 2. Okay, then after that you're gonna say minus the 8x to the power 2. Then when you're applying the rules now, that's when you're gonna write dy over dx, and then you're gonna say 3 over 2x to the power of a half minus 16x. Then that's how you use that notation. Now the differential notation, what it does, or how is it different, is that now instead of having the equation written as y is equals to something, the differential notation, you're gonna have it already like this. The question is given inside of the cube, the bracket there. That's where you get the question. But when you're applying the rules, you don't write dy over dx, you write equal sign. So for differential notation, when you're applying the rules, you just write equal sign. Then you start 2 times 3 is going to be 6, and then x, then 3 minus 1 is 2. Then negative 4 times 2 is what? Is negative 8. Then 2 minus 1 is 1. You see, the only difference is that for the differential notation, you write equal sign only when you're applying the rules. But the rest of them, you write dy over dx or dk over dy, or depending on the question. Number 2, let's say you have differential with respect to y. Here is the letter we are respecting, by the way. Let's just say we have 3y cubed minus 2x. So when I'm applying the rules, I just write equal. Then I say 3 times 3 is 9. And then I have y, 3 minus 1 is 2. But then now here I have x, and I'm supposed to respect y. So because I have x, I take that as a what? As a constant. So I simply have to say plus 0. So my answer will be 9y squared. So that is how the differential notation works differently from dy over dx and the rest of them. Are we clear? That's clear. Right. So let's just do maybe one last one. Right. One last one and see how we can do that. Let's just say we have x is equals to 2k to the power of 5 minus k to the power of 4. Right. Let's say we needed to, then they say to you, find the following. Okay, let's have minus x squared there. No, let's say minus y cubed there. So let's say they say to you, because they're gonna give you the questions, they're gonna say to you, find dx over dk, right? And then they're gonna also say find dx over dy, right? So how do we do the first part? The first part is that x must be the subject. Yes, is the subject. Then k must be the letter you are respecting. K must be the letter you are respecting. So here we're going to apply the rules. I'm already writing this because I'm applying the rules. 2 times 5 is going to be 10. And then I have k. 5 minus 1 is 4. Then here minus 1 times 4 is minus 4. Then I have k. What is 4 minus 1 is 3. Then here, because it's y and it's not k, then I have to write that as 0. So my answer there would be 10k to the power of 4 minus 4k cubed. That would be the answer there. While this side, I have to respect y. So since here I'm seeing k, this whole thing we take it as a constant. So I'm going to have 0 plus. Since here I'm only seeing k, it's going to be 0 again. And then now here I have y. Now I can say minus 1 times 3 is what? Minus 3y. And then minus 3 minus 1. 3 minus 1 is 2. So my final answer for dx over dy would be equal to minus 3y squared. So you must always just take note that when you are looking at dy over dx, this notation, this Leibniz's notation, you must take note that this means this is the subject of the formula, but then the one at the bottom there means the variable you must respect. All the other variables, we will take them as constants. I hope that this is clear, guys. Now, I hope that you know how to apply differential rules, differentiation rules. So the next time is that we're going to look at the derivative from first principles.